Hello and welcome back. In the last video, we talked about what a quadratic function is. We basically established that a quadratic function is a function that has an x squared term. And in this video, we're going to be looking at what a quadratic function looks like on a graph. So why don't we consider the most basic quadratic function? Y is equal to x squared. So I'll bring up a graph and a table. And we're just going to go about this the way we would normally go about graphing a function that we haven't seen before. Okay, so we're going to use a table of values, and we're going to start off with x is equal to 0. So if we plug x is equal to 0 into the equation, we'll have y is equal to 0 squared, which is 0 times 0, or 0. So we have that for x is equal to 0, y is equal to 0. And that is our first point on the parabola. Okay, we'll try x is equal to 1 for our next point. So if I plug in x is equal to 1 into the equation, I'll have y is equal to 1 squared. And 1 squared is 1 times 1, or 1. So we have that for x is equal to 1, y is equal to 1. And again, we'll plot that point. And now we'll do x is equal to negative 1. If we plug negative 1 for x, we'll have y is equal to negative 1 squared. That is equal to negative 1 times negative 1, or 1, because a negative times a negative is a positive. So we have that for x is equal to negative 1, y is equal to 1. Again, we'll plot that point, and now we have 3 points. Okay, and using the same idea, if I plug in x is equal to 2, I'll get y is equal to 4. I'll plot that point, and if I get x is equal to negative 2, I'll have y is equal to 4. Okay, and lastly, we'll connect the points, and we'll get our parabola. So this is generally what a quadratic function is going to look like. Now, of course, we can shift it and stretch it and compress it, but the basic graph for a quadratic function looks like this, and it is called a parabola. Okay, we'll do another quadratic function. Y is equal to 2x squared minus 3. In this function, again, we have our x squared, so we know that it is a quadratic function. We're following the rules. In this case, we're multiplying it by 2 and subtracting 3. So we're using multiplication and subtraction. That's perfectly okay. And again, I'll pull up a data table. And again, we'll start off with x is equal to 0. So if I plug x is equal to 0 into the equation, I'll have y is equal to 2 times 0 squared minus 3. 2 times 0 squared is 2 times 0, or 0. So we have 0 minus 3, or negative 3. So we have that for x is equal to 0, y is equal to negative 3. So I'll plot that point on the graph, and we can do another one. We'll try x is equal to 1. Plugging that value for x into the equation, we'll have y is equal to 2 times 1 squared minus 3. 2 times 1 squared is 2 times 1, or 2. So we're left with 2 minus 3, which is negative 1. And we have that for x is equal to 1, y is equal to negative 1. Okay, and we'll try x is equal to negative 1 again. If we plug that value for x, we'll have y is equal to 2 times negative 1 squared minus 3. 2 times negative 1 squared is 2 times 1. So that gives us 2 minus 3, or negative 1. And we have that for x is equal to negative 1, y is also equal to negative 1. I'll plot that point on the graph. And using the same idea again, we'll plug x is equal to 2 into the equation. That will end up giving us y is equal to 5. And plot that on the graph. We plug x is equal to negative 2 into the equation. That will give us y is equal to 5. Plot that on the graph, and once again, we can connect the points on the graph to get our graph for the quadratic function, or the parabola. Okay, so now we have a general idea of what parabolas look like. Right now, what I'm going to do is go over two important characteristics that we deal with a lot when looking at quadratic functions. And I'll use the two parabolas that we just recently sketched. You'll notice that each of these parabolas have a minimum value. that minimum value is called their vertex. So with the first parabola, it's actually at the origin. So the vertex is the point 0, 0. The second characteristic is the x-intercept, which is also called the zero or the solution or the root. So it has many different names, but we're going to call it the x-intercept for now. It's called the zero because it is basically referring to the values at which y is equal to 0, which we know is on the x-axis. So in that case, because it intersects the x-axis at the point 0, 0, we have that the x-intercept is 0, 0. Same idea with the second graph, the minimum value is the vertex. So in this case it is 0, -2. In terms of the roots, we can see that the parabola intersects the x-axis at -1 and 1. Therefore the x-intercepts are -1 and 1. So we have that the x-intercepts are 1, 0 and -1, 0. So for a point on the x-axis, the y value is always going to be equal to 0. So we just have to look at where it intercepts the x-axis. In this case, it intercepts the x-axis at -1 and 1. Now there are 2 points that I want to make. The first point is that the parabola does not have to have its vertex located on the y-axis. So it can be shifted to the right or to the left. For example, with this parabola, we can see that it has been shifted to the right. Once again, the vertex is the minimum value, and we have that value is 3, -1. It intercepts the x-axis at the points 2 and 4. Therefore, we have that the x-intercepts are 2, 0 and 4, 0. The other important thing to know is that the parabola does not always have to open upwards. It can also open downwards. And in that case, the vertex is actually the maximum value. So with this particular case, we have that the vertex is 3 and then about 1.5, so 1.5. So in general, whenever a parabola opens upwards, we know that the vertex is a minimum value, and when the parabola opens downwards, we know that the vertex is a maximum value. And once again, this parabola intercepts the x-axis at the points 2 and 4, therefore the x-intercepts are 2, 0 and 4, 0. So that's all I wanted to go over for this video. In the next few videos, we'll be going over techniques that will make it a lot easier for us to convert the standard form of a quadratic equation into other forms that will allow us to get the x-intercepts and the vertex right away. But for now, as always, thanks for watching.